Alright, in this video we're going to drill the holes in part number 2. This first little bit here, I'm using those ultra thin parallels because before I drilled the holes in this part, I had drilled holes in another part in this project, but I'm just editing the videos in this order. So you don't actually need to have these thin parallels on this part. Regular 1/8 inch parallels will work. And actually, if you look close, you'll see that I'm using a vise stop to build the vise stop. So the vise stop that I'm using, I'm choosing to take the contact point and position it to be dead center of the part. There's some advantages to doing that as opposed to just the edge of the part. Standard edge finding operation. I went over till the edge finder jumped to the right. Then I lifted it up above the part and moved over another 0.100 thousandths. So right here with the center drill, you'll see I only center drill the tip diameter. I don't go down into the 60-degree included angle. It's a lot easier on your next drill bit if you don't center drill all the way down into the conical section of the center drill. And that's why, you know, a spot drill would also be very suitable. But for whatever reason, it's very common that we just take our center drills that are for the lathe and we use them as spot drills quite often. But yeah, no, let's go back to talking about the drill bit. So anytime the drill bit is making contact with a pre-existing hole or a really large center drilled hole, when it first touches, it's only on the cutting edges, it's on the lips. The web or the chisel edge is not making contact. Where right here, you know, the tip of the drill bit's going to touch first, and it's going to give us an easier start on the tip of the drill and the cutting edges. In fact, you can even buy spot drills that are a broader angle than 118 degrees, so that way the tip will touch first. And I was kind of plowing through this. I think I was in quite the hurry when I was drilling this part. But I do stop and I add some oil. Now you see the chips are turning blue. That's because the material's getting thin at the bottom of the hole. In most machine shop, like you know, actual machine shops, not classrooms, we'd probably be using a tool mist right now, and that'd be a mixture of our actual regular coolant that we run in the CNC machines, and it's being blown as a mist against the cutting tool and onto the part. And the tool mist greatly reduces the heat buildup, but it makes a mess a lot faster than you'd imagine for only being applied as a mist. You can make some puddles pretty quickly. But these holes, these are 17 32nd holes. The print says 0.530, so it rounded down. And then this hole here is, the print calls it out as a 0.460 hole. I've never used this hole on any vise stops or any vices that I've been around, but I think it should make it to where it would adapt to a 4-inch wide vise. And it was on the original print, so I just keep on doing it. So here I am. I'm going to countersink all of the holes. It's not on the print, but I'm just gonna break the edge enough to give it, well, just to clean it up and make it look nice. Now, a lot of times, um, in my previous work experience, when I would deburr holes like this, I would often do it at a drill press with a single flute cutting countersink at a low RPM. Or if the part's bigger, I've deburred hundreds um, of holes with a cordless powered drill motor and a single flute countersink, because it doesn't take a whole lot of force to just break that edge. And then of course we have our hand deburring tools as well. But you want to make your parts as clean and professional as you can possibly make them. Now you see here when I flip the part over, this is where one of the benefits of having the stop locating to the center position on the part, not just the edge, because if the side of the part, when I say the edge. Now in this instance my part has been faced, but if it wasn't faced, if it was a crooked saw cut, then I would have a lateral shift of the part in the x-axis. And also, if you're not dead center in your y-axis, or if you're off center in your x-axis, you'll see it when you touch down with a countersink like this. It'll make the elliptical ring appear off center. Now these might appear off center, but that's because the camera's at coming in at an angle, and you'll see that in a couple seconds. But you can see when I hold the part up, everything's concentric. And I was showing off, you want to have good finishes whenever possible. Yeah, so I went ahead and I made a decision. I haven't formally changed this on the print yet, but I decided I'm going to drill and tap half 13 holes so I can screw bolts into my stop, so that when it's in my toolbox, it's 100% ready at a moment's notice to be put to use on a milling machine. Because the stop that I had on that vise that I was using, I had to walk around the first drawer, didn't have any bolts that were the right size, then I had to walk over the tool room. And big picture, as a on-the-floor machinist, you had to eliminate every single extra set of steps or time walking away from your machine. So I'm going to let all you students go ahead and center up and drill and tap your own half 13 holes in your vise stops if you want. And I'll probably eventually add some dimensions on a print. But this is mainly, I included this because my thumbnail picture for all these videos, if you noticed, there was these extra holes, and I thought, well, since they've been looking at these extra holes that aren't on the print, I better at least include them on a video and explain why they're there. So that's a .421 diameter hole. And now I'm going to countersink it out to where the diameter of the countersink is slightly larger than .500. And that countersink, it does look like it's off a little bit in the y-axis. I don't remember noticing that, so I don't know if it's just a camera, a little bit of a weird angle coming in, because that one doesn't look as bad, so I'm not too sure. But I go down, I power tap the half 13 holes. I'm using a tap driver I'm not holding it in a drill chuck. Use a tap driver when you can, or hand tap with a pilot to guide the tap going straight. Now this part, all these parts, I'm going to go ahead and probably at some point get a picture of the parts when they're at their current state of bead blasted, so that way you can't see the chuck bite marks on that part like you can right now. And then I bead blasted them, and then I also use the cold bluing, so they have a real nice black, flat black look. But pretty happy with the appearance of the parts using that method. And there I am, I'm showing you that that's where that bolt's going to go when it's bolted to a machine. But when it's hanging out in the toolbox, it'll have some bolts waiting for you to use them. Alright, that's the end of the video.